Hello, this video is to help work through some of the problems in 5.3a notes. Specifically, I'm going to work on 4, 5, 9, and 10 on this video. So let's go ahead and take a look at number 4. The very first thing to look for is a GCF. This one has no GCF. However, there are two terms and they are both perfect squares and they are separated by a minus sign. So what we can do is we can do the difference of two squares. So you want to think about what squared gives you the 16x to the fourth, and that would be 4x to the second, because 4x to the second times 4x to the second gives you 16 and then x to the fourth. Likewise with the y to the fourth, it would be y squared as your second terms. And because this is a minus sign here, you're going to have a one positive and one negative, because when you distribute all of this out, your middle two terms then would cancel each other out. Then normally you would circle this as your final answer. However, you ask yourself, does this factor further? So if we were to kind of cover up this second factor and look at that first factor, you'd say, no, that one does not factor further. But if we were to cover up this first factor and look at the 4x squared minus y squared, we would say that that does factor further using the difference of two squares. So the first term stays the same, 4x squared plus y squared. And then the second factor is going to become a 2x plus y and a 2x minus y. This then would be the final factored form because nothing else keeps going. So for number 5 here, looking at this one is pretty challenging because it has the x's and the y's. So as you're looking at this, I want you to pretend, first of all, that the y's aren't there. If this just said 9x squared minus 24x plus 16, we would look at this and we would say, okay, well, what multiplies to get 9 times 16, or 144, but yet adds to get negative 24? And we would come up with the numbers negative 12 and negative 12. So what we're going to do is the same idea here. It's just that you have a y's on there as well. Now, the only reason that this is going to work is because just like it says x squared and then one x in the middle and then no x's for your third term, notice how your last term has y squared, the middle term has y, and then the first term doesn't have a y. So it's following the same pattern as your x's that the y's are. It's just going in reverse. So what we're going to do is we're going to rewrite 9x squared by itself. We're going to rewrite 16y squared by itself as well. And we're going to split the middle two terms, or the middle term up, into the numbers that we got when we pretended like it was just the x's. So we got a negative 12 and a negative 12, but instead of writing negative 12x like we normally do, we're going to take this term and leave it as xy. So now, factoring by grouping, the first two terms have a 3 and an x in common, and I would be left behind with 3x minus 4y. The next two terms here have a negative 4y in common, and I would be left with 3x minus 4y. And we can tell that this is working because now these factors are the same. So we're going to take 3x minus 4y out, and then we're going to be left with 3x minus 4y as well. And because we can write it the same thing twice here, we can write it as 3x minus 4y quantity squared. If you left it out twice, that's totally fine though. That's saying the exact same thing. So now let's go ahead and take a look at our challenges. So starting at number 9 here. As we're looking at this, there's a lot going on here. So I want you to, if you haven't thought about it yet, pause this and try and think about something first, and we'll see if it works. When I look at this one, I see that there are tons of terms. So then I think about, okay, what happens if I have a lot of terms? I try grouping. And in the past, what we've done is just like our last example, we cut it in half and group the first two together and the last two together. And there's equal amounts in each group. But for this one, we have an odd number. So instead of grouping it with a group of 4 and a group of 5, they have to have the same numbers. So I'm going to group it by 3. I'm going to first look at these first 3 terms and what they have in common. They have an x squared in common. And left behind would be x squared plus x minus 2. The next group, that has a 4x in common. Left behind would be x squared plus x minus 2. That last group has a 4 in common, and that would be x squared plus x minus 2. Now, if this was all of the hints that you needed to keep going with this problem, go ahead and do this problem on your own from this point. Otherwise, we can go ahead and take a look at these groups. All of the groups are x squared plus x minus 2. And what would be left behind if we factored the common factor out then would be the coefficients, which would be x squared plus 4x plus 4. Now, getting to this stage is a challenge in and of itself, but now as we look at this, there's something happening with this first one. We can actually factor this further. We can look for what multiplies to get negative 2 and adds to get 1. It'd be x plus 2 and x minus 1. Now the second part also factors further. What multiplies to get 4 and adds to get 4 would be x plus 2 and x plus 2. And you can actually circle this as your answer, or you can clean it up a bit. I can see that there are 1, 2, 3 times that x plus 2 is multiplied, and x minus 1 only happens once. So it would be x plus 2 cubed times x minus 1. So now I want you to take a look at 10a and 10b. So for 10a, this is more of like what you've seen before. You're looking for what multiplies to get negative 8 and adds to get negative 2. And you go through your whole factoring process, and we should get 3u plus 4 and u minus 2. Okay, so that's from before. If that's a struggle, come and see me. We should probably talk about that factoring of that, okay? So we get to this point here, and that would be our final answer. So if you look at 10b, the reason why this is both called problem 10 is because it actually has the same kind of bones in both of these problems. Right here, where it says 2x minus 1, on the first problem, it says u. So if 2x minus 1 was u, we would have problem 10a instead of 10b. And that we could factor. We've already factored that part. So to go back and think about how 10b is now, instead of writing u, so we factored it, like I said, like normal with 10a. Instead of writing u, I'm going to plug in 2x minus 1 in its place. I would have 3u plus 4 and u minus 2, but I'm no longer writing u, I'm writing 2x minus 1 instead. So all I've done is factored it like I did in 10a and plugged in 2x minus 1 instead of u. Then we can go ahead and simplify things. 6x minus 3 plus 4. This all would combine to be 6x plus 1. And then the next one combining like terms would be 2x minus 3. So we've now simplified the part that's up there in pink into the part that's in there in blue, and none of those factor further, so that is done. Now that is very involved. There's a lot going on there. So the good news is we will keep on practicing this, and you'll have plenty of time to ask questions about it and try more practice problems. So thank you for listening. I hope this helped, and let me know if you have any other questions. Thanks.